My dear student, welcome to my online class. Hope you are well by the grace of Almighty. Today I am going to discuss about Unit 9, Lesson 5, Future Aircraft. Now look at the pictures and say what they are. Lesson 5, Future Aircraft. Now let's jump into the vocabulary first. Withstand, meaning remain undamaged, unaffected by or resist. Space, meaning a continuous area or expanse that is free, available, or unoccupied. Hypersonic, meaning related to speed more than 5 times the speed of the sound. Let's watch the video.
With hypersonic transport, we'd be able to travel to any part of the world in 3 hours or less. Let's talk about the challenges and ideas behind making this a reality. Going hypersonic means traveling at a speed more than 5 times the speed of sound, which would be Mach 5 or 3,835 miles per hour. I recently made a video about the development of supersonic commercial airliners, but even as those are yet to be released, several governments and private companies are currently engaged in a race to hypersonic flight. The official record for fastest manned jet aircraft has been held by the Lockheed SR-71 Blackbird since 1976, a reconnaissance plane capable of flying above Mach 3. Experimental hypersonic planes have been flown in the past, but all have been powered by rocket engines or rocket boosters, which are extra heavy because they require carrying the oxygen used to fuel them, as well as being extremely inefficient and not particularly reusable. What we're talking about in this video is the development of a manned hypersonic jet aircraft that can take off, fly, and land on its own like a regular airliner or fighter jet can. Sounds simple enough, but as we learned when discussing supersonic jets in a previous video, weird stuff happens at high speeds that makes certain thresholds a complicated hurdle to cross. There are 3 main problem areas that must be overcome to successfully build a hypersonic jet: what materials to use, how to design the craft, and the proper engine to use. Standard commercial aircrafts are made of aluminum because it's a strong, lightweight, and inexpensive material. Unfortunately, an aluminum plane would melt at hypersonic speeds, as would common stronger materials like steel. Heat on the body of the plane can reach temperatures of up to 5,000 degrees Fahrenheit and up to 12,000 degrees Fahrenheit in the engine. This is partly explained by the skin friction created by the airplane pushing air out of the way at 5 times the speed of sound, which is called aerodynamic heating. Heat is also produced by shock waves created when traveling above the speed of sound, which is a rapid compression of air caused by air literally not being able to get out of the plane's way fast enough. As you can imagine, this also produces massive drag, which not only affects the speed of the aircraft, but can also damage materials and reduce its lifespan. But Julian, you might be saying, that's my name by the way, we've sent a plane into space before. You may have heard of the space shuttle that took people to the ISS and back. What was that made out of? And why can't we just build hypersonic planes out of the same material? That's a great question and a convenient segue, thanks for asking. Mainly, space shuttles and hypersonic earthbound planes have significantly different uses. Space shuttles are designed to make a small number of trips, whereas hypersonic jets would be making several flights per day and traveling within the Earth's atmosphere at hypersonic speeds for relatively long periods of time. Spacecraft solve the issue of extreme aerodynamic heating caused by re-entering the Earth's atmosphere at high speeds using tiles made of different materials based on the amount of heat the part of the plane they were on would be facing, which you've probably heard referenced to as a heat shield. While this worked well for the few minutes it takes a space shuttle to re-enter the Earth's atmosphere, it doesn't work quite as well for a hypersonic airliner traveling for hours at a time, because the space shuttle tiles, while extremely poor conductors of heat, are also very fragile. The main focus of the research into these materials is focused on some sort of ceramic tiles reinforced by carbon-carbon material at the points getting the brunt of the heat, the nose and the leading edges. But these materials can be rather susceptible to damage from debris, which as shown by the Space Shuttle Columbia disaster can be extremely dangerous. The Space Shuttle Columbia itself used ceramic tiles and reinforced its leading edges with carbon-carbon material. It was damaged to this heat shield from debris that led to its destruction upon re-entry. entry. Clearly, engineers will have to come up with a material that is much, much safer if we ever want to see hypersonic flight become a reality. It seems for now, however, the answer is creating more durable ceramics. British and Chinese scientists working together made a breakthrough last year with a new process for creating carbides, which are ceramics formed by combining carbon with other materials. They start with reinforced carbon-carbon, which is a matrix of carbon reinforced by carbon fibers. Then, using a process called reactive melt infiltration, they infuse the carbon-carbon with zirconium, titanium, more carbon, and boron. The carbon-carbon structure absorbs these materials, and the resulting material is a carbide that retains the flexibility and strength of the original carbon structure, but with much higher resistance to heat. In fact, it's about 12 times stronger than zirconium carbide, which is currently used to dissipate heat in things such as drill bits and reusable rockets. There is a lot more progress needed in materials before it's safe to use on a hypersonic plane. Following the materials and heat issue, although not unrelated, is that of what engine do you use on a hypersonic plane to maximize fuel efficiency and actually achieve the necessary speed. There are 4 kinds of engines one might consider: turbojet, ramjet, scramjet, and rocket engines, which we already discarded as an option at the beginning of this video. In my video on the comeback of supersonic planes, I discuss why a turbojet engine is best to achieve supersonic speeds. However, a turbojet engine doesn't cut it if you want to fly at hypersonic speeds, because it caps out around Mach 3.5, short of the Mach 5 requirement to go hypersonic.
Look at the pictures. Read the news reported after from The Guardian. The Falcon Hypersonic Technology Vehicle 2, Falcon STB-2, is the fastest plane ever built by the human beings. The Falcon Hypersonic means the speed of more than 5 times the speed of the sound. Technology means the application of scientific knowledge for practical purpose, especially in industry. And vehicles too is the fastest. This is the superlative from the plane ever built by the human beings. Ever built, constructed, and founded by the human beings means mankind. It would fly from London to Sydney in less than 1 hour. It would fly. Fly means travel through the air. London to Sydney in less than 1 hour. It can fly from London to Sydney in less than 1 hour. Supersonic Concorde. Supersonic means greater than the speed of the sound. The Concorde, the plane supersonic Concorde means the supersonic speed plane Concorde. By the by, could not fly at such a great speed. Could not fly means cannot travel through the airs. As such a speed means look like the Falcon HTB-2. At the same time, simultaneously, it would withstand temperature of almost 2000 degrees Celsius. It would withstand means can be resist or tolerate or hold out against, and temperature means the degree or intensity of heat present in the substance or object. Almost 2000 degrees Celsius. That means the plane hypersonic technology vehicles Falcon STB-2 can tolerate the temperature almost 2000 degrees Celsius. This temperature is hotter than the melting point of the steels. The US Defense Agency will launch the Falcon STB-2. The US Defense Agency was launching a start of again the Falcon STB-2. First, they will set it on the back of the rocket. First, they started the back part of the rocket, and they will launch both into the space from an Air Force base, and they will start and both into the space from an Air Force base, started from the Air Force base. The plane goes like this. Engineer will launch the Falcon STB-2 into the space on the back of a rocket, and the engineer will start at the Falcon STB-2 into the space on the back of the rocket, and they started this Falcon STB-2 in the back part of the rocket, and then they will detach the plane from the rocket, and they will detach. And detach means separate, segregate, or free from the plane from the rocket, and plane Falcon will fly towards that, and then the plane Falcon will start flying and traveling to the air from the rocket. After detaching from the rocket, the Falcon started flying towards the Earth. An engineer will guard the monitor it in the flight. The engineer who is sitting inside the Falcon, he will guide the monitor in it the flight. The plane would fly in the hypersonic speed of 13,000 miles per hour. That means the speed of the hypersonic Falcon vehicles HTV-2 is 13,000 miles per hour. The speed is about 20 times the speed of the sound. The hypersonic Falcon vehicle HTV-2 is speed is 20 times of the speed of the sound. The Falcon was born in 2003. This initiative was taken was in 2003. It was born as a part of the U.S. military budget. It is started as the military budget of the U.S. military, and the project features and built in a special type of plane. The project features been investigated or studied, built or constructed in a special type of plane. The researchers, the investigators, and wanted that the plane could reach the part of the world in less than an hour. They wish the plane could reach and could travel from one part to another part within less than in 1 hour. And they also wanted to use it for any purpose. They tried their best to use this in different purposes, military or civil. The plane was already tested in a computer model. The plane already tested, justified in the computer model. The Falcon Hypersonic Technology Vehicle 2 would be mankind's dream aircraft in the days to come. The Falcon Hypersonic Technology Vehicle HTV-2 would be the mankind's dream, mankind fantasy or visions aircraft in the days to come, in the future. Now answer the following question. What is the HTV-2? Question number 2. What is the speed of HTV-2? Question number 3. Describe the steps of HTV-2 test flight. And question number 4. Why was the HTV-2 developed? Question number 5. Do you think that HTV-2 will be the mankind's dreams worker? Why do you think so? Do the activity see imagine you are the TV reporter. You have come to interview the chief engineer of the HTV-2 launch project. What question will you ask him or her? Design a short dialogue between yourself and the engineer and write it and finally act it out in your peers. Your homework is make a poster on the future aircrafts. Have a nice life. Stay home, stay safe. Thank you.